We're at 10 o'clock, everybody. Welcome to Filter's air filtration webinar and reducing airborne pathogens in your facility. Right? That's what I'm talking about. We keep it exciting. We keep it awesome. And we're going to keep it real, okay? With real knowledge, not my buddy says, okay? Your buddy says, like I said before, we'll get your room killed. We want to deliver sourced information for you guys. We want to make sure that everybody's feeling confident about this next level of what you need to do in your grow facility in order to get to a retail shelf. You'd be surprised. Sometimes you can grow the best, sweetest leaf on the planet, but if you can't pass a microbe test, it's just a cool trick, okay? So we need to start to break down the parts of the grow room that are creating problems on this level and learn how to attack them more aggressively and with coming from a base of knowledge. So here we are, air filtration and reducing airborne pathogens in your facility. So let me just kind of give you a little bit of an intro on myself and the company. My name is Jason Hadley. I'm with Filter Science. Filter is manufactured by Lighthouse Worldwide Solutions. You're like, who's Lighthouse Worldwide Solutions? Well, I'm about to tell you. So Lighthouse Worldwide Solutions, we are, we're huge. I'm not gonna lie. We are headquartered in Fremont, California. We do research and development, we do pilot production, we do service and installation, finance, accounting, quality assurance for highly controlled, highly regulated industries. We also are manufacturers of real-time particle monitoring systems, air samplers, particle counters, filter, wink, wink. We are manufactured out of Medford, Oregon. We also do calibration and instrument servicing. We do system build-outs, quality assurance, project management, etc. Now, we call ourselves Lighthouse Worldwide Solutions. The worldwide, no joke, okay? Again, we're headquartered in Fremont, California. We're manufactured in Medford, Oregon. We have a training center in Arizona. We have a calibration facility in Philadelphia. And then we also have offices overseas, where we're in Thailand, Malaysia. We have offices in China, offices in the Netherlands, and offices in Turkey. So some of the markets that Filter's parent company, Lighthouse Worldwide Solutions, services include like semiconductor manufacturing. We got aerospace, automotive, pharmaceutical, medical device. And we moved into horticulture. Why did we move into horticulture, you may be asking, is because frankly, the level of spec that cannabis needs to operate at is roughly around semiconductor, aerospace, pharmaceutical, medical device, the cleanest possible environments, okay? Food production. What you're looking for, you want to Google the term CGMP, Current Good Manufacturing Practices. So we'll touch on that in a little bit. Some of our more notable clients in the life sciences industry, you'll notice we work with like some pretty popular companies these days. Johnson & Johnson, Pfizer, we work with Moderna, not pictured here, but Novartis, Bayer. We also do a lot of work in electronics. That includes like semiconductor, aerospace. So we sell to NASA, we sell to Raytheon, Intel, SpaceX. Tesla is our next door neighbor and a client of ours. And then of course we move into the indoor agriculture space, where we've been working with companies like Jungle Boys and Tweed. We do work with Cookies, Happy Healing Farms, Cannabis up in Oregon. So we do quite a bit of stuff. And again, coming from a regulatory perspective, really helps to kind of have that eye on the facility. So we're going to be covering 5 things in this webinar, okay? We're going to be covering the basics of microbes and understanding their size and scale of the problem. We want to talk a little bit about why current indoor agriculture facility design kind of, in effect, exacerbates a lot of microbe problems just by the nature of their design and the way that they operate. Third thing we'll cover is HVAC filtration basics, and we want to give you a working knowledge of what HEPA filtration is. We'll follow that up with why supplemental air filtration is important, where your current HVAC system kind of underserves the environment. And lastly, we'll just kind of do like a quick comparison of HEPA to other air disinfection technologies that are common in cannabis. You see a lot of them out there. And we'll take a look at kind of where they fall short from the perspective of microbe control within cannabis specifically. And let me just say up front for that particular point about comparing other technologies, a lot of these other technologies are totally viable technologies. They're fine as far as like what they do. I simply make a case for the idea that they're not beneficial for cannabis. Okay, so just kind of keep that in mind. If I'm sounding like I'm knocking the competition, you know, I try to avoid a lot of the tribalism that you see with people who have like a favorite nutrient company or a favorite soil medium or whatever. So anyway, so those are the 5 things we're going to be covering: microbe basics, current age facility design, HVAC basics, why supplemental filtration helps, and how that compares against other stuff that's out there. So let's dive in. So let's start off with some microbe basics, okay? By the way, in case you're wondering, that's a water bear. That's like a real thing, very, very tiny, and can live in all sorts of conditions. It's crazy. All right, moving on. So microbe basics, okay? So to give you an idea, the problem that you're trying to get out of your air is at the micron size. So to put that into perspective, these are problems that you cannot see with the naked eye, okay? Normal light can actually perfect light conditions, and like you just ate a bag of carrots. That's about like the level of like optical acuity you have to be able to have to see down to like as small as 35 to 45 microns. Okay, like you have to have the eyesight of a hawk to do that under perfect lighting conditions. So this chart here is basically kind of showing you some of the comparisons of different sizes of particles so that you get kind of a little bit of a scope of the problem. So you can see we have a human hair for comparison, and then we go down into finer beach sand and grains of salt, and then we start getting into blood cells. And so your mold spore family, your mold spore, basically, actually, let me say this, anything you're concerned about from an air filtration standpoint, or let me say even more specifically, anything you're concerned about from a plant pathogen standpoint is 1 micron and up, okay? That's your target. Everything that you build in from a microbe control standpoint, the size that you're looking to kill is anything about 1 micron and up from your air, okay? So just to give you an example of some of the more like relevant pathogens in cannabis, mold spores typically range from 10 to 30 microns. And powdery mildew, for example, ranges from about 30 to 50 microns. Hold on a second, I gotta take a step here. That's some good H2O. All right. So just want to give you kind of a set it up for the size of the problem, the scale of the problem you're dealing with. To see that in a little bit more of a perspective, okay, what you're looking at, that's a flea, okay? I did this during another webinar, but so some of this is recycled material, but bear with me. If you didn't see the other webinar, by the way, we'll get you a link to that. Just put it in the Q&A section. And if you do start to develop any questions along the way, make sure that you do fill out the Q&A section as well. I should also take a second for quick housekeeping before we go into this, that there is a survey at the end of the webinar that I want you guys to take. It's really helpful to us to be able to guide these webinars towards the kind of information that you guys are really looking for, all right? So let's take a look here. Dig that crazy. That's a diatom on a flea, but the thing you're really trying to get is that. That is a bacteria. We'll look at it again. Look at that. Bacteria on the back of a diatom that is on the eye of a flea. So you have to remember, everything rides on the back of everything that rides on the back of everything. Here's mold spores. This is really what you're trying to filter out of your air, okay? So those are mold spores up close, right? This is CGI, but this is what happens at their scale. Those are spores that are breaking off. So every one of those spores produces that one, every single mold spore produces a single stalk, and that single stalk produces like 10,000 more spores. So their reproduction rate is incredible. And so you want to be able to get that out of your air. And every one of those spores is trying to find something, an ideal condition to settle on and thrive. Okay, so that also helps on why you keep a lot of dead plant material out of the room, as well as pulling out anything that is organic, which I mentioned in the last webinar. But anyway, so let's understand the problem of airflow. All right, let's move on to airflow. So here's what's going on, and here's what's ideal, okay? So in cannabis, we typically tend to operate under what's called a turbulent airflow environment. So turbulent airflow environments include the HVAC system that's pumping in from the ceiling or pumping in from a windsock or however your HVAC set up. And then you have, very likely, I would assume, a lot of supplemental fans that are blowing air around the room, right? We're trying to blow a lot of air around to keep air off the plants for powdery mildew, what have you, right? So this is what's called a turbulent air environment. The air is constantly churning, moving, recirculating in and out of the space. Let's also not forget that people walking through the space are also going to be creating airflow and wind flow at a scale that's going to affect airborne pathogens. And let's also not forget doors opening and closing as well. So versus the other side here is what's called unidirectional airflow. This is the kind of airflow that they use in pharmaceutical clean room manufacturing. So what they do is they set up a grid on the ceiling that is a bunch of downward flowing fans, and the entire room, the pressure of the air is stabilized coming down all at the same time, all at the same speed, and then that air goes into returns at the bottoms of the floors, and there's actually a dead wall space between those two between the outside walls. The air circulates back up to the top of the room and goes back down. So what they're trying to do is circulate as much of their own air as possible, right? And so what are they trying to get out of the air, right? So particles, short word, full stop, particles. What's a particle? A particle is anything. A particle is dust. A particle is a mold spore. A particle is, pollen, what have you, right? So you have to understand that particles in air are very susceptible to airflow at their scale. You have to remember that a whisper to us is a Category 5 hurricane to a microbe or to a plant pathogen or to a particle. So what you're looking at is a chart here where they take a particle of the sizes that you see up at the top and they drop it into a tube that has like no airflow in it, right? It's not affected by airflow. They drop it into a 1 meter long tube, and that's how long it takes for that particle to fall 1 meter in still air. Okay, that's in still air. So think about it this way: your plant pathogen sizes are 1 micron and up. A 1 micron particle in still air, perfectly still air, still takes almost 5 hours to fall 1 meter. Right? 5 hours. So meaning with your fans, with your HVAC, with your people, with your doors opening and closing and push carts and reaching into the canopy and what have you, like those particles are continually aloft in your air. They don't have a way, the air is never really going to be still enough for them to fall to the ground. Maybe the heavier particles for sure, but those light particles that you're concerned about, okay? So we know getting the mold out of the air, right? We get mold. So why do we care about dust, right? We don't think, oh, well, dust doesn't, grow into anything. Well, not so fast, okay? So dust can carry larger particles of dust can harbor bacteria, virus, and in some cases mold, depending on the size differential between the two particles. But my point is that dust is the vehicle by which some pathogens travel, okay? Let's set aside for a moment that you want the dust out of the room because it settles on the tops of the leaves, obscuring photosynthesis, and it gets attracted to the stoma underneath the leaf and can create blockages that will prevent the plant from properly breathing and stress the plant out. Right, okay, let's set that aside for a second. From a pure airborne filtration standpoint, you want to get anything and everything out of the room. So you can see the photo on the right where this is actually happening. And you can see that there's a ragweed pollen spore right there, and powdery mildew spores are attached to that ragweed. Okay, so sometimes, in fact, if you're getting one particle, you may in fact be getting two problems at once. But again, you want to get anything and everything out of your air. You want your air as clean as possible. I promise you. Just take that, write it down. Okay, so let's get into the basics of air filtration and HEPA. So kind of the thing that like is the big question mark, I guess, is like, or the trade-offs that happen is you have to consider cooling capacity on one hand, but you also have to consider your particle filtration on the other, because you need a beefier unit in order to get more airflow, in order to get with a thicker filter to filter out more problems, more particles. So oftentimes, and a lot of facilities that we go into, that HVAC decision's already been made, and they didn't really factor particle because they didn't have to at the time. Remember, and nobody cared about particles until like 5 or 6 years ago. Before that, it was just cut the moldy part off, put the rest back in the bag. So yeah, you can see here we got to choose between cooling capacity and particle filtration. I think this gentleman answered with particle filtration, considering he's sweating. So that's my analysis of that. Let's see here. By the way, let me also take time to mention, we have a survey after the webinar. Please feel free to send us any Q&A questions, and also suggest any future topics. All that stuff totally helps us. So, excuse me, getting back to it. What is an air filter? Let's just define it. We all know what it is, but let's just define it. An air filter is a barrier between incoming and recirculated air and the areas said air is serving, and is composed of a fibrous or porous material for the purpose of removing solid particulates such as dust, pollen, mold, and bacteria. All right, did everybody memorize that? Repeat it back. No, I'm kidding. Okay, so there's 3 different kind of main types of filters that you'll see in HVAC systems. There is what's called a panel filter. Panel filter is just like a sheet of woven material, and they just sandwich it into a frame. Boom, bam, you're off to the races. Then there's what's called a pleated filter. A pleated filter is, as you can see, there is like a zigzag pattern of the filter media, and that's to create more surface area within the filter to catch particles. And then some HVAC systems, depending on their size or who makes it or what have you, they'll have what's called a bag or pocket filter. And a bag or pocket filter acts similarly to a pleated filter in many ways. It's just again, providing more surface area. So the key takeaways from the filtration, from the actual filter cartridge, and what makes it a kind of filter that it is basically the material composition, the thickness of the media, and the amount of surface area that is available to catch particles, okay? So how does air filtration work? It works on the basis of capture and removal, okay? So there's a lot of devices out there that claim to kill a pathogen in the air. You don't have to do that. Like, Pfizer doesn't do that. Moderna doesn't kill particles in the air. They go with an old school method of capturing and removing particles. Okay, we'll cover some of that for a second. So capture and removal, as you can see from the photo, this is an operating suite. And as you know, operating suites have to be extremely sterile. And one of the things that they do is they have a lot of airflow. They have a lot of high rates of air exchange. And I believe like hospital operating rooms are somewhere in the neighborhood of 25 air exchanges per hour. And that's in a pretty tight space. So again, they're just basically trying to recycle and refilter as much of their own air as possible. So capture and removal relies on really aggressive exchange and continual exchange of the air. Again, it only requires you to remove the offending particle from the space and just simply trap it within the filter. And this process is a standard in pharmaceutical manufacturing and other clean room environments. Again, I would urge you, this doesn't even just apply to air filtration. This applies to your entire facility, from the way that you build it to the way that you operate it. Look up these 3 things: CGMP, USP 797, which is the US Pharmacopoeia, that is the standards for building, 797 is the standards for building non-sterile compounding facilities. And then there's another one for sterile compounding facilities. This will tell you like what kind of floor materials you should be using, what kind of air filtration, HEPA. I'm just telling you, we'll cover that in a second. And then the FDA has a guideline called 21 CFR Part 211. It is called the guideline for finished pharmaceutical products or something to that effect. I'm just going off memory. But anyway, you can Google all 3 of those. I highly advise you start familiarizing yourself with that, because those are the standards that you need to be operating at. And if you can get to that standard, I guarantee you're going to be a lot more successful. So piggybacking onto the idea that basic air filtration relies on continual capture and removal of particles. Again, if you're recycling as much of your own air as possible, you're creating an effect called dilution, where you're diluting the dirty air in your space with ever cleaner air. So the more you can recirculate as much of your own air as possible without makeup air, you know, you're going to be continually removing particles, and every time that air goes through, a little bit more of the particles are going to be removed. Now, you're never going to get down to zero. That's not going to happen. Don't even dare to dream it. Like, trust me, millions upon millions of dollars are spent just to get right above particleless. Okay, so and also don't forget that this dilution effect is also going to kind of reset itself, unfortunately, every time a door is open and hallway air comes in. This is also about learning to like kind of keep your rooms, you know, your pressure equal in your rooms between your hallway and your grow rooms, to prevent like when you open the door and you feel a bunch of air rush in, that's all the air from your hallway poof, going right into your room. And we all know that the hallway is your main artery of your facility that everybody's crisscrossing back and forth. By the way, stop crisscrossing back and forth. So let's see. So what happens within a filter? Okay, how does filtration actually work? So there are main principles of how the actual mechanisms of filtration. So if you take a look at this photo here, and we take into account that the blue arrows are the airflow, the green arrow with the dot is the particle. There are five total types of basic filtration practices that are going on here. So we have what's called sieving, you know, this is actually where a particle is traveling and gets caught between two particles, right? It gets impinged, if you will. So the next way that it works is by interception, where it just sort of makes its way and like kind of curves into a filter fiber. And then there's direct inertial impaction, which is where you have a particle and you have a fiber, and boom, they just land right on top of each other. So then there's also two other kinds of filtration that are primarily for like far smaller particles than you need to be concerned about for cannabis. You'd want to be concerned about them if you were fighting COVID. But like, so there's diffusion or Brownian motion. Best way to describe it is to say that it's like the random travel of particles making their way to a filter fiber. But really what's going on to a certain degree is that the particle that you're capturing is small enough that it's able to be affected by like VOC molecules, and it bumps into stuff that's like at a much smaller scale, like at a gas phase. And that creates, it's sort of like if you've ever seen like underwater nature videos, and you see all those little bits when they turn the light on from the submarine, and all those little bits that are floating in the water. That's Brownian motion. They're just going everywhere and they're at the whims of wherever. But from a very ultra fine particle filtration standpoint, it works. It does its thing. So lastly, the last mechanism of filtration is electrostatic attraction. And this is basically, you've done this as a kid where you took a balloon and you rubbed it on your head and you put it on a wall and it stuck and you're like, I'm a magician, right? Ta-da! No, this is an actual thing. So like things are positively charged and negatively charged, and they attract to each other at a small enough scale. So that's what's going on. So we have sieving, interception, inertial impaction, diffusion, or what's called Brownian motion, and electrostatic attraction. And then the picture on the right is a microscopic scanned electron microscope photo of what the filter media looks like with stuff on it. So you can see the scale, that little horizontal white line just underneath the letter A is a 10 micron line. So that's your measuring guide on that. So you can see a lot of the particles that are there are like at the 1 micron level, right? If you probably took like 10 or 12 to complete that line. So I just wanted you to be able to visualize what's actually happening on the inside of a filter. That's what it looks like. When we pull a filter cartridge out, it just looks gray and dingy, but that's what it looks like at its scale, all right? So now you're like, well, how do I know what the right filter is for me? How do I know that, you know, what filter I should be using, right? So filters have what are the air cartridge that's in your HVAC has what's called a MERV rating, or what's called a minimum efficiency reporting value, okay, MERV. So this is basically a standard for rating filters so that there's consistency in manufacturing. This was started by ASHRAE. ASHRAE is an organization that sets standards for HVAC industries. So you can see that the MERV rating scale goes from 1 up to 16. In reality, truth be told, it goes like up to 13, and then you start getting into the HEPA scale. But again, if we're talking about 1 micron particles and larger, you know, a MERV 8 rated filter, which is typically used in like home and office applications, it's catching less than 20% of what you need. So when you built your spot out and you have your air conditioners on your roof or your handlers in your hallway or whatever it is, you know, that filtration rating is only going to capture so much. So higher rated filters, as you can see from the chart, they capture more particles. Like, so ideally you'd want to be at a MERV 13 because it's catching 90% of or better of anything that's 1 micron and up. And now we're starting to get into like, you know, mold spores and dust harboring bacteria and those types of things. So how do you check your filter rating? So luckily, every filter, as you can see from the picture of the filter with the circle on it, every filter will have like a MERV rating on the side, okay? And that'll tell you. So you just basically have to go into your HVAC unit and take a look at that filter and go buy another one, all right? So sometimes the product manual may have some suggestions on what to do, or like any warnings to like not put a certain higher rated filter into your unit. Because here's what's happening is like you're saying, okay, well, we're using MERV 8 filters, cool. Let's throw some 13s in there and see what it does. But here's the problem is it's a thicker filter media. It's a thicker filter media, so you're gonna have to produce more air pressure to get through that filter. So if your unit is constantly running in order to produce the air pressure to go through that, if it's not producing enough air pressure, it's going to back pressure. If it's you know, having to constantly force air through, your unit is constantly running, which will affect the product life cycle of your HVAC in general. And as well, if you're running too high of a unit of a MERV rated filter in there, you have to change it way more often than you would with a lesser rated unit filter. Your filter schedule is going to increase dramatically. Okay. So anyway, so then as far as air filter change out tips, all right. So here's a couple of things to take away. Okay. Number one, you got, and I use the air filter that's right for your HVAC system. Avoid pack pressuring and loss of climate control. So if you're using an air filter that's rated too high for the air conditioning system, you're going to start to see like all of your temperature sensors in your room are going to start rising. You're going to start getting all sorts of alerts and what have you. So that might be an indicator that the filter that's in your HVAC system is too much and you need to back it down, okay? You want to stay on top of maintaining and changing your HVAC filter cartridges. I cannot stress that enough. Whether you just develop it as an SOP, okay? That every time you do a room reset, you change out your filter, or if you're using a higher rated filter, you might have to change that more often. So also, make sure that you're replacing your filter cartridge correctly using the airflow arrow on the edge. So again, using that same filter in that red circle, there's an arrow at the top of that filter. So every one of these filters is going to have an arrow on it, and that's going to tell you which way you want to install the filter to make sure that it's facing the correct direction for airflow. Somebody here is learning that for the first time, okay? So finally, if you took one thing away from me with regard to air filtration and mitigating airborne pathogens within your space, or pathogens in general, BIBO, bag in, bag out, okay? This is a process that is used in the pharmaceutical industry. Now, keep in mind their HVAC systems are designed for this because this is a standard within their industry. So their filter basically has like a cartridge that goes around the outside of where they would pull a cartridge out. And they basically knot off a bag, reach in, pull the filter out, knot the bag off on the other end, tie it off, and then cut. And that what that does is it basically creates an area for the filter to not release any particles as it's being jostled Because typically, you know, if you've ever changed an air filter and you're up on a ladder, God forbid you drop it, now you've dislodged all that crap that is in your filter. It's now all over your floor. It's going to get kicked up back into the air, and you're now putting it back into the facility. So if you're not going to bag in, cool, whatever, that's your choice. But I would highly implore you, suggest, demand, mandate, build it as an SOP, try to bag it out. So I've seen some people do that where they take a 50-gallon contractor bag and just tape it to where the outside of the filter is where the outside of the filter is residing, and then reach in, pull it out, knot it off, tie it off, get it out of there, okay? Now, you may be thinking, okay, well, I got a rooftop unit. I'm not inside the building. Still, those particles can attract to you, and you can bring them into the building if you don't have any proper gowning procedures, okay? So now we're going into HEPA, okay? We're going into HEPA. So, and we may go a little bit longer and cut the Q&A time because I just love doling out information. So let me give you a brief history of HEPA. So HEPA was discovered back in around World War II. Somebody put some paper filter in a gas mask and they found out that it worked wonderfully under those conditions. So then the Manhattan Project comes along and they're like, well, we want to develop this type of air filtration to be able to remove radioactive material from the air, right? It's becoming the atomic age. So they employed this Nobel laureate named Irving Langmuir, who basically identified, after a bunch of testing, he identified the most difficult particle to filter out is 0.3 micron. So if you look at this chart next to that mugshot, you're going to see there that there's like kind of a dip, right? The lowest point of filtration is that 0.3 micron. So what's weird is that it's easier to filter out particles that are 0.3 and larger, but it's also easier to filter out things that are 0.3 and smaller. Again, that's where electrostatics and Brownian motion come in, where again, you start to get into those larger particles. You're talking about sieving, interception, and direct inertial impaction. So from there, you know, HEPA becomes refined, it becomes trademarked, it becomes applied to pharma, aerospace, semiconductor, all that sort of stuff. But here's the crazy part is it is a very reliable technology. My filter that I sell, that I'm going to talk about in a little bit because I'm going to get a little commercial time in, our most penetrating particle size, right, 0.3 that you're seeing there, ours is 0.2. So it's like the level of improvement of the technology has been consistent since the 50s, right, since its discovery. So how does it compare to regular HVAC filtration? So HEPA filter basically operates at about a 99.97 effective rate. So meaning for like every 10,000 particles that go through that filter, only 3 are coming out. 3, okay? So it's a heavy amount of filtration, and I included a little bit of a microscopic blow up of what is going on inside of a HEPA filter. So it's a bunch of fibers, like nanofibers that are spread around, and they're antimicrobial and what have you. So again, that most penetrating particle size, you can see here, it's, as I'm using my mouse pointer, I don't know if you can see that, but the HEPA line is like right above just the top of the graphic itself. MERV 16, right, which is what I was talking about before. I think MERV 13 before you start to get into the HEPA scale, but you can see that the efficiency of HEPA far exceeds any of the MERV rated filters, okay? So HEPA, high efficiency particulate air. That's what it stands for in case it ever comes up on trivia night. So why would you want supplemental air filtration, right? Because if your HVAC unit isn't producing enough particle filtration, well, then you have to supplement that with air filtration, right? You're still trying to get the pathogens out of your room. It's not like you're like, oh, we have a MERV 8 unit. Oh, well, what do we do? No, you put in supplemental filtration that directly attacks the problem. So that's so much easier to do because it's cheaper than having to rip out and replace an entire HVAC system that already satisfied the cooling needs of the room just to be able to have better filtration. That just doesn't wash with me. Like if you weren't cooling in the room down enough and you were having mold problems, I'd say, okay, you gotta do a rip out and replacement, right? But if one part of the problem is being solved, but the other one is, you could just bring in the thing to solve the other problem. So supplemental air filtration, much like filter, it works independent of your climate control. It doesn't interfere with your HVAC, okay? And second to that point is that it's specifically built to attack the particle problem. I mean, you don't even have to have HVAC in the room for a filter to do its job. You want to for obvious reasons, but my point in saying that is that we're specifically built to reduce what's called particle pressure. Okay, the particle pressure, the volume of particles that are in the air, and specifically attacking that. Okay, so and by the way, let me take a quick mention before I dive into this chart. We got a survey after the webinar. Please help us in refining the quality of the webinars that we deliver to you. If you have questions, make sure you put them in the Q&A box. If we don't get to your question, we'll answer it personally. I'll answer it after the webinar. And of course, we also want to make sure that we suggest future topics that you guys want us to talk about. Because again, it's not just about air filtration, it's about the facility as a whole. Okay, and that's what we want to give you. So here's a quick poll that came up. What topics would you like for us to cover for our next webinar? Right, product demonstrations, contamination control, how to, building SOPs, contamination control basics, anything. You can always just email us. So here, I'll tell you what, let's dive into this chart here. If we can move that out of the way. I'm gonna move that out of the way. Okay, so I kind of took a moment to want to break down some of the basic air disinfection technologies that are currently out there. Okay, so I've compared basically HEPA, photocatalytic oxidation, which is like a product like AeroClean 420. Just regular standard ultraviolet light, like I believe Air Sniper, I think is like just straight UV. And then hydrogen peroxide vapor, which is like Innovative Solutions or ProGuard, whatever they go by, just for purposes of example. So core technology in HEPA, and I'll try to blow through this as quickly as possible, and you can screenshot this or you can go back and look at it later when we post the webinar live. But I just want to give you some basics. So HEPA's core technology, air, we're just channeling as much air as we can through a filter. Okay, just capture and remove, capture and remove. You don't have to kill, you just got to get it out of the space. Okay, photocatalytic oxidation works a little differently. It's a UV light that shines onto titanium dioxide. That light reaction creates what are called hydroxyl radicals, and air passes through that box in order to be exposed to that reaction and then goes out on the other end. Ultraviolet light is a little bit different. If you've ever seen an ultraviolet light wand, for example, it's just basically shining an intense enough light at the right frequency in order to eradicate a particle. And then hydrogen peroxide vapor is, again, it's another light reaction at its core, but it produces hydrogen peroxide gas vapors, and those aerosolized droplets combine with the airborne particles in the air. Okay, so now I want to know, well, what are we asking of the particle? Because we have this technology, but is it actually doing the thing, you know, working with the particle's behavior in order to like actually create an eradication? So what's being asked of the particle in HEPA is we're just saying, hey, get sucked into our net, right? So your particle's being drawn through a microscopic antimicrobial netting, similar to, but finer than existing AC filtration, okay? So think about this for a second. You already accept the proof of concept of HEPA, because if you've ever walked into an air-conditioned room, that has air filtration in it. If you've ever driven a car, that has air filtration in it. If you've ever used a shop vac, that has air filtration in it. So air filtration is nothing new to anybody, and we know that it works, and you just know that you got to change your air filters, right? Cool. What we're doing is a bigger, beefier commercial version of that captures things at a better level than all the other stuff that you're used to seeing, okay? So what's being asked of the particle in PCO? So the particle has to be slowed down inside the box in order for that reaction to take place. So they claim to kill this particle, and if that eradication doesn't take place because the particle has not been exposed for long enough in that reaction, well, it goes right back out in the environment. Whoa, that's not good. And if it's dead, it's food for something else. If it's live and it hasn't been completely killed, it's now back into the environment to find a new space in order to thrive. With ultraviolet light, the particle, again, you're creating exposure time or minimum contact time. But with a UV light, the light has to be at a very specific distance and held for a very specific amount of time. For example, it takes 30 seconds to kill COVID under UV light. So if you were to try to put UV lights in your air conditioning system in order to maintain that contact time, you would need to have 500 feet of straight air duct with a UV light in it in order to achieve that 30 seconds at like a, you know, your average HVAC system. So it's like not really wildly efficient. So then what's being asked of the particle with like a ProGuard? So they're sending out all these little particles, right? And then they're said that they're attacking all the particles that are in the air. But it's just like that scene in Braveheart where you have an army on one side, and you have an army on the other, and they all run into each other. And yes, some of them get caught up, but some of them do get through to the other side. Okay, you're asking a lot of that particle because you're asking something that's susceptible to the wind to hit something that's susceptible to the wind in midair. Right? This is the analogy I tend to use is if you had a cloud of baseballs coming at you, which would you rather have? Would you rather have another cloud of baseballs to knock it out of the air? Or would you rather just like go stand behind the backstop and let that do the work, right? Because that's more like HEPA. So how can the efficiency of these technologies be measured? So HEPA can be instantly measured with using a handheld particle counter. You can literally hold a handheld particle counter up to the output, and then you can hold it or to the inlet, and then you can hold it to the output, and you can see an actual reduction in the particles that are coming out if in fact it's removing particles. You can also see if it's not removing particles as well. So now to test the effectiveness of PCO, ultraviolet, hydrogen peroxide vapors, you have to be able to take a sample of the air that's either in the room or that's coming out of the device. Okay, and then send that Petri dish off to a lab. Okay, that's like a 5 to 10 day process from the time you send it off to the time you get the results, right? The lab has to grow out the samples, incubate the samples, and what have you. So that means, so here's the thing that you need to worry about, right? Well, I don't mean to scare anybody, but this is the thing that you need to be concerned about, is that if it takes 5 to 10 days to determine you have a problem, that means you're 5 to 10 days behind the 8 ball on the solution. You feel me on that? So in other words, with HEPA, you can tell if there's a problem right away. With these guys, you can't tell these guys are working for like a week. Okay, so just kind of take that in. Lastly, does any of this technology across the board satisfy any future regulatory compliance? Okay, so dig this, right? CGMP right now is kind of an option. It's not mandated. But let's put it this way, come future federal legalization, who is most likely to take over the management and oversight of the cannabis industry? I'll stop you right here, save you the time. It's going to be organizations like the FDA, Department of Agriculture, BATF for taxes and such. So in other words, HEPA air filtration is already compliant to a compliance level you may eventually have to achieve. So this is a way to invest in that now and start with that now. So that come future compliance, you're not rushing trying to figure out what to do, and you don't have to, your learning curve didn't just suddenly shoot up, okay? So again, HEPA air filtration already currently standard in industries that operate at higher cleanliness standards as per law within outside of cannabis and above cannabis. And you always want to look to regulatory worlds that are operating at a cleanliness level higher than where you're at, right? They're the guide. And that information's already out there. If you want it, just DM me, man. I'll send you whatever you need, dude. My brain's your brain, bro. So, okay. So HEPA currently satisfies, again, 21 CFR Part 11 mentions HEPA. USP 797 mentions HEPA 37 times. Ask me how many times it mentions PCO, UV, or hydrogen peroxide vapor. I'll save you the time. 0. All right, so, and then of course it's obviously CGMP compliance. So to kind of sort of put all of this into a nutshell, and again, hit me up with questions. This webinar will be available offline. A link will go out. We do have a survey after the webinar we're going to ask you to stick around for again. We also have Q&A box. If you have questions, if we don't get to your question, we'll answer it directly. Please, please, please feel free to suggest future topics you want us to talk about, because we can talk to you all day about how things should be, but we want to know, how is it really in your place and where can we get you to that next level of operational cleanliness? So if we were going to take kind of recap everything that we just went through. I would say point number one, Lighthouse Worldwide Solutions, my company, filters company, has a lot of experience serving the monitoring needs of some of the world's cleanest environments. The big takeaway is we're kind of a big deal, okay? All right, so number two, microbes are ever present in your air. Just understand that and accept that. Accept that they're very small, accept that they move very easily, and they're always looking for an optimum place to settle and breed. It's nothing personal, just mold just be doing what mold be doing. Mold just be molding, okay? It's an opportunist, and all we're trying to do is reduce the opportunities for that mold to take place and take hold in the room. So again, removing these particles from your air is essential to reducing their volume. And I would probably venture to guess in many cases, your current HVAC filtration may not be adequately doing the job. So point number four, the air quality needs for cannabis make supplemental HEPA air filtration, such as filter, a plug and play solution for clean room grade air. Where all your dirty air is coming from, we can discuss on the phone. You can call me. That's cool. We'll do that. But if like, as far as getting your air clean, continually recirculating your air is key. Okay. And with that said, the technology that we deliver, we didn't invent anything. Okay. HEPA air filtration is way established since the 50s, as we saw. It's a validated technology. The current standard in pharmaceutical and other like critical manufacturing areas. And just take this in that it is the eventual and inevitable standard within cannabis. So you may want to start at least just asking questions and poking around now, okay? So that said, I offer a heartfelt thank you for allowing me to present some information to you. Again, my name is Jason Hadley. I am a sales engineer with Filter. You can feel free to email me directly, jhadley@golighthouse.com. As well, you can always feel free if you didn't find me through, if you found me through some other means, I'm available on Instagram under Dyslexic Stoner 402. I assure you, I post a lot of microbial contamination control tactical stuff. So let's see here. So that said, let's do a couple of little Q&As here, and I'm seeing we have a question from Oliver. And he said, are there any products that produce particles and contribute to the problem? So like products that might be like within the cannabis facility, I'm assuming based on the question and what we're talking about. So are there any products that produce particles and contribute to the problem? Yes, actually there are. Your HVAC system, you want to clean them, make sure that that's clean, that your ducting is clean. You know, your fans, you want to make sure that your fans are cleaned as part of a cleaning SOP, because remember, you're growing fly paper that gets you high. Like all of those little terps are floating in the air and sticking to stuff, right? So your fans get mucked up really easily, and then that stuff dislodges and spreads throughout the room. So keep your fans clean. Also, shop vacs, man, make sure you change your filters on your shop vacs. Not to knock Quest, but because I think they stopped making it at this point, but they were making this fan that like blew air from your floor up into your canopy to like get the CO2 off the floor. Cool idea. The only drawback from it was that it also pulled all the stuff off of your floor and shot it back up into the air as well. So from a microbe control standpoint, I think they came out with their own HEPA too, by the way, but you know, here we are. Questing isn't going to do this. So let's see here. We have another question. How can I test how dirty my air is? Okay, great question. Because what you need to do is you need to get a bead on where do you stand right now? Like what's your level of cleanliness at this point, right? Where are you starting from? So a couple of the devices that, actually here, I can do a quick show and tell. Bear with me a second here. I happen to have them nearby, is two devices that, wouldn't you know what we happen to sell. One of which is a handheld particle counter. Can we see that? Is that, no, there we go. The handheld particle counter. This basically will measure particles in the air, will tell you if you have any anomalies within your space that may require further testing. And what would you test further with? Well, you would test further with what's called an air sampler. This is an air sampler. You would take this off, you put a Petri dish on, you put it on, it takes a measured amount of airflow at a very specific speed, and with that, you have consistency in your sampling to be able to detect mold and dust and stuff in your air. There's also another device that is out there called a spore trapper. This is ideal for capturing powdery mildew spores and being able to test for powdery mildew in your space. My air sampler is great at doing what it does. Sorry, I had to shut it off. My air sampler is great at doing what it does. The only problem is powdery mildew doesn't plate on agar. Okay, like the device isn't inferior. It's that powdery mildew is obligatory and it has to live on the plant, but you can still capture the spores, but the spores don't land on malt extract agar, malt, yeah, I think MEA plates, malt extract agar. So yes, you can test by taking air samples. You can just leave a Petri dish out, let it settle for 15 minutes, send it off to a lab. Not very efficient, but you know, it can help get you there. Let's see. So we got a question from Hannah, and Hannah asked, how can I see if my HVAC ducting is harboring a problem? Okay, great questions. So this would again kind of go back to the lab sampling answer to the question. So I would highly suggest if you were going to want to sample your HVAC, you would want to sample off of the coils to make sure that there's nothing being produced there. I would make sure to sample your swab out your ducting at various points in the process, probably like right after the filter and at a couple of points in between. I would also make sure to take swab samples or lift, like put a piece of tape and lift it off and put it on something, you know, call an industrial hygiene lab. I highly suggest you call in and start working with an industrial hygiene lab. These are guys whose whole job is to like test for cleanliness within food and pharma and other regulated industries. So they have an eye for this already, and they can offer the testing methodologies that work best for their equipment. So we have some people that work with labs that are like, I want it on a dish and you got to do it this way. And other people are like, just put a piece of tape on the doorknob and pull it off and send it in and let's see what's on it. So there's a few different ways to test that. So you're going to want to test your venting, like the venting grates on the return, the venting grates on the output, just to make sure, you know, what's going in and what's coming out, man, you know. You may also want to even take a piece of your filter itself, you know, cut it off at some point and send a piece of it into your lab and see what's on it. Not a bad idea. Glad I thought of it. Let's see. All right, we got another question from John here, and John says, why do the filter rating numbers at Home Depot look different than the MERV rated chart that you showed us? Good question. Okay, so the MERV rating chart that we saw earlier is a standard chart by ASHRAE. Right? They're the standards organization for HVAC, okay? Home Depot, for whatever reason in their infinite wisdom, decided that they wanted to come out with a different rating system. So what you kind of need to do is understand the MERV rating system and then understand the Home Depot rating system if that's where you're getting a lot of your air filter cartridges from, and be able to tell like where the equivalencies are. So I unfortunately don't have a Home Depot air conditioning filter with me handy, but you definitely want to make sure that there's some sort of equivalency in what you're doing. And usually it'll indicate what you're trying to filter out. So, you know, take a look at that. But I know on their website, I've seen it in the past where there is a way to equate the Home Depot scale to the MERV scale, which would tell me, well, why don't you just do it by the MERV scale? But that gets into a question for Home Depot. So, all right, so we got one last question here. We got one last question from Paul. Paul, you're awesome for logging on, first and foremost. His question is, do the UV devices you mentioned that you compared, do they produce ozone? Good question. Some of that you may have to research, okay? I will tell you this, that UV typically has like two favorable spectrums. One is 186 nanometer, and the other is, let me take a look at my notes, 254, I believe, 254 nanometers. So 186 nanometer UV is the type of UV light you would use in an ozone generator that you would use like a few years back when you just needed to clear out the air, right? That's an ozone generator. 186, that produces ozone, as I just said, because it's an ozone generator, right? 254 nanometer doesn't produce ozone, right? So you need to check the product packaging or the product specifications and look at the nanometer rating of the UV light that's inside the device, okay? However, be aware that some devices will use what's called a dual spectrum bulb, which I'm sure you know from lighting, from plant lighting, is that, so they have a combination dual spectrum of 186 and 254, but it still can produce ozone. So for instance, I'm in California, and California devices have to be certified by CARB, the California Air Resource Board. This is a device that, or this is a governing body that oversees that devices that are being used by the consumers are not producing ozone for obvious air quality reasons. So CARB has a list of approved devices, which, hey, you'll find filter on, but you'll also find a couple of these other guys on as well. So if your state has like high air quality ratings or air quality management oversight, they very likely have a list of approved devices. If it's not on there and you're using it and it comes down to like maybe you have an inspector or an auditor in your facility and they're seeing that you're using something that is not technically legally allowed to be sold in the state, it could result in some fines or what have you. I don't think they're going to come call the UV police on you or anything like that, but you know, you definitely don't want to use it, number one, because it's an air quality issue, and number two, because ozone eats your terps, man. You're spending all this time growing all this quality plant, and then like it's got no nose, man. What do you want to do? You know, you're not making chicken feed, man. We're making quality, top shelf, you know, primo, and it's like you need to get to a retail shelf with the most fragrant and potent product possible. Ozone does not help that. All right, so that said, I think we're going to cut it off on questions here, but let me also, first and foremost, again, offer a very, very hearty thank you for attending today. If I didn't get to your question, I will answer it directly. I see a couple here that we're, you know, kind of pressed for time on that are kind of bigger answers. So Mike, I see your question. James, I see your question. Eric, I see your question. I will get to you. I'll answer it offline here after we're done with the webinar. This webinar link will be available online afterwards. I'm not sure when it'll be released, but I'll post it on IG and all the other social media networks. I assure you, you'll know about it. Please do take a moment at the end of this to take the survey that's at the end of the webinar. This will, again, help us guide that we deliver the best information that you find the most useful. I would also make it a point to, if you're on the IG, make sure you follow @filter_science. That's FILTR science. You're like, why don't you spell it with an E? And I was like, well, they kept putting the E on, but the filter kept, you know, sucking it off. I'm kidding. Okay, so also, again, if we didn't get to your questions, I'll answer them directly. And then please, please, please make sure that you suggest future topics, because we want to know what you need to know, okay? I can tell you all the information, but if none of it is what you're actually asking for, it's not really helpful. So let's start by asking the questions that are yearning and burning within you, and then we can work our way out to the things that you also need to learn, but maybe you didn't think of, okay? So that is our time here. That is our hour. You guys have been absolutely amazing. Again, please take the survey afterwards. I do want to thank the filter team in the control booth for helping guide me through this on the back side of it, and as well as just kind of helping me bring the knowledge of contamination control as an added value to air filtration that you may or may not already understand, but there's so many other questions when it comes to cleanliness within your facility that go way beyond the filter, and we are there for you. All right, so you guys have a wonderful day. Be well, stay safe, grow strong, keep fighting the good fight, get the airborne particles out of your room. Adios.